Welcome. Vigilant, the mind behind the defense. AI-driven intrusion detection and response system. Developed by Mashkur Alam. Overview. Vigilant, AI-driven intrusion detection and response system, is a comprehensive, enterprise-grade network security platform that combines traditional intrusion detection with cutting-edge machine learning, explainable AI, and automated response capabilities. The system provides real-time threat detection, intelligent alerting, and automated security orchestration to protect network infrastructure from cyber threats. Key highlights. Multi-layer detection, 4 parallel detection methods, threat intelligence, anomaly detection, supervised classification, signature-based. AI-powered, isolation forest for anomaly detection plus XGBoost for attack classification. Explainable AI, detailed explanations for every alert, making AI decisions transparent. Automated response, SOAR engine with 9 priority-based response policies. Human in the loop, active learning from analyst feedback to continuously improve models. Real-time monitoring, live traffic analysis, real-time dashboards, and instant alerts. Scalable architecture, Docker-based microservices with message queue integration. Comprehensive UI, modern, responsive web interface with advanced analytics. Architecture overview. The system follows a 3-layer microservices architecture, data ingestion for capturing network traffic, AI processing for threat analysis, and automated response for protective actions. We use Docker containers orchestrated with Docker Compose for consistent deployment and scalability. Core components. At the network layer, Suricata and Zeek act as our intrusion detection sensors. Suricata provides signature-based detection while Zeek offers detailed traffic logging and metadata extraction. These complementary tools give us comprehensive network visibility. The Elastic Stack handles log aggregation. Fibeat collects logs from our sensors and Logstash processes and enriches this data before forwarding to our application. This pipeline architecture decouples collection from processing, enabling independent scaling. Our backend uses Python Flask with a RESTful API architecture. We chose Python for its extensive machine learning ecosystem, including scikit-learn and XGBoost, while Flask provides lightweight, flexible API development. The application follows object-oriented design with clear model classes for intrusion events, alerts, block type keys, and threat intelligence data. PostgreSQL serves as our database, chosen for strong ACID compliance, ensuring data integrity for security audits, excellent query performance for analytics, and proven enterprise scalability. RabbitMQ implements our message queue, creating an asynchronous event-driven architecture. Events flow through queues rather than directly to the database, preventing system overload during attack surges and ensuring no data loss. AI and machine learning. We employ a hybrid AI approach. Our supervised XGBoost classifier, trained on the CISID's 2017 dataset, identifies known attack patterns with over 95% accuracy. It analyzes features like packet sizes, protocols, and payload characteristics to classify threats. Complementing this, isolation forest anomaly detection catches zero-day attacks and novel threats that don't match known patterns. This unsupervised approach identifies unusual network behavior deviating from established baselines. The explainable AI service generates human-readable explanations for every alert, detailing which features contributed to classification and why. This transparency builds analyst trust in automated decisions. Our active learning pipeline continuously improves accuracy. When analysts provide true positive or false positive feedback, this labeled data retrains the models, customizing them to your specific environment. SOAR engine. The security orchestration and automated response engine automatically blocks high-confidence threats, monitors suspicious IPs, and escalates based on severity thresholds. It operates in simulation mode for testing or active mode for automated enforcement. The front end. The web interface uses JavaScript with jQuery, Bootstrap 5 for responsive design, Chart.js for visualizations, and Leaflet.js for the interactive global attack map. This stack provides simplicity, browser compatibility, and rapid development without framework overhead. Why this architecture? Every choice prioritizes real-time performance for instant threat detection, modularity allowing component upgrades without disruption, explainability so security teams understand and trust AI decisions, and scalability from small networks to enterprise deployments processing millions of events daily. The combination of proven open-source tools, robust infrastructure, modern machine learning, and clean software architecture creates a system that's both technically sophisticated and operationally practical. Let's start. Now, let's see this architecture in action with a live demonstration of the system. AI-driven Vigilant dashboard. Welcome to the Vigilant dashboard, your central command center for real-time security monitoring and threat response. Let me walk you through the key components. SOAR engine status. The SOAR engine status shows our security orchestration, automation, and response system mode. Simulation mode detects and flags threats without automatic blocking, ideal for training and testing. Active mode enables automated blocking of malicious IPs based on AI threat assessments. This toggle gives you complete control over automated response aggressiveness. Live traffic monitor. The live traffic monitor displays your network's real-time heartbeat. The traffic stream shows network packets as they flow through your system, source IP, destination, protocol, and timestamp for every connection attempt. Live metrics provide instant visibility into total packets processed, active connections, bandwidth utilization, and detection rates. These continuously updating numbers help spot unusual patterns or sudden activity spikes indicating potential attacks. Latest threats highlights the most recent security events with threat type, severity level, and AI confidence scores. High-confidence threats here deserve immediate attention as the most credible security risks. Global Attack Map. The Global Attack Map visualizes real-time geographic origins of detected attacks. Each point represents a potentially malicious IP address. Hover over any point to see IP details, country of origin, and attack count. This geographical intelligence helps you understand attack patterns and implement geo-blocking policies if needed. Recent alerts. The Recent Alerts table is your threat intelligence feed, showing chronological security events. Each alert displays the alert ID, timestamp, source IP, attack type, like SQL injection or port scanning, severity level from low to critical, and the confidence score calculated by our XGBoost machine learning model indicating detection reliability. Actions: why, true positive, false positive. The actions column enables human-AI collaboration. The why button opens our explainable AI interface, providing detailed, human-readable explanations of why the AI classified activity as malicious, showing which network features contributed most to the decision. True positive confirms the AI correctly identified a real threat, helping the model become more accurate. False positive indicates the system flagged legitimate traffic incorrectly, providing corrective feedback. This continuous learning loop ensures Vigilant adapts to your specific network environment, reducing false alarms while maintaining high detection rates. Alert explanation. Alert explanation provides transparency into every decision. Unlike traditional black box systems, our explainable AI generates comprehensive breakdowns, including the detection method used, supervised learning, anomaly detection, signature matching, or threat intelligence correlation. Key features influencing the decision like unusual ports or suspicious payloads, attack classification with confidence percentage, and actionable recommendations for response. This transparency builds trust in AI decisions and provides valuable learning opportunities for your security team. The dashboard combines AI speed and scale with human judgment and expertise. Vigilant doesn't just detect threats, it explains them, learns from your feedback, and adapts to your environment, making it a true partner in your cybersecurity defense strategy. Analytics and Insights. Welcome to the Analytics and Insights module of Vigilant. While the dashboard provides real-time monitoring, this suite delivers the deep intelligence and historical context needed for strategic security decisions. Let me walk you through each component. Export Analytics Reports. First, our Export Analytics Reports feature allows you to generate comprehensive security reports with a single click. Export in PDF for executive briefings, CSV for data analysis, or JSON for system integration. This eliminates hours of manual report compilation and ensures consistency for compliance, audits, and stakeholder communications. Executive Overview. The Executive Overview distills thousands of security events into 4 critical metrics: total alerts detected, percentage blocked by automation, current threat level trends, and overall detection accuracy. This color-coded dashboard answers the key questions every executive asks. Are we under attack? Is our defense working? And are we improving over time? Real-time threat monitoring. Real-time threat monitoring provides aggregated trend analysis of emerging threats over the past hour, day, or week. The charts show attack volume trends, severity distribution, and detection method breakdowns, helping you identify if attack activity is increasing and which threat types are most prevalent. This enables proactive resource allocation based on current threat patterns. Detection Engine Performance. The Detection Engine Performance section shows how well each AI model is performing. You'll see metrics for supervised learning, anomaly detection, signature matching, and threat intelligence, including detection counts, accuracy rates, false positive percentages, and model confidence distributions. This data helps you tune detection thresholds to balance security coverage with alert fatigue. SOAR Automation and Response Metrics. SOAR automation metrics quantify the value of automated security orchestration. View total automated responses, average response time from detection to action, typically milliseconds versus manual hours, success rates, and the ratio of automated versus human intervention incidents. As the system learns, Automation rates increase while maintaining accuracy, directly reducing your mean time to respond. Attack surface and geographic intelligence. This section provides a comprehensive view of where attacks originate and how your threat surface is distributed globally. Understanding attacker geography helps inform geo-blocking policies, regional access controls, and compliance reporting, especially for organizations under data sovereignty regulations. Top 10 attacking IP addresses. The top 10 list identifies your most persistent adversaries, showing IP addresses, attack volumes, primary attack types, and current status. This focused view lets you prioritize investigations, identify reconnaissance campaigns, and recognize distributed attack patterns where multiple IPs coordinate their activities. Top source countries. Top source countries shows the national origins of detected attacks, ranked by malicious traffic volume. While attackers often use compromised systems in various countries, this data helps identify targeting patterns, informs geo-blocking decisions, and provides context when correlated with known threat actor profiles. Geographic attack distribution. The geographic attack distribution heat map visualizes attack density and severity across regions, often down to city level. Color intensity indicates attack volume or severity, revealing threat hotspots and geographic clusters. This is particularly valuable for organizations with distributed operations to understand which locations face the greatest exposure. Threat intelligence integration. Vigilant enriches AI detection with external feeds from abuse.ch and commercial threat databases. This panel shows threat intelligence match statistics, data freshness, and correlation between AI detections and known indicators. The hybrid approach validates AI decisions, reduces false positives, and catches zero-day attacks not yet in threat databases. Temporal attack patterns. Temporal attack patterns reveal when attacks occur through time series visualizations by hour, day, and week. These patterns show attack surges during specific business hours, weekly variations, or seasonal trends. Understanding temporal patterns optimizes security resource allocation, monitoring schedules, and automated response sensitivity based on actual threat timing. "24-hour attack heat map." The 24-hour attack heat map uses color gradients to show attack intensity across each hour. Darker colors indicate high activity periods, making patterns immediately visible. Segmentation by attack type reveals if different threats follow different schedules. Unusual patterns during normally quiet hours indicate new threat actors or methodology changes requiring investigation. The Analytics and Insights module transforms raw security events into strategic intelligence. Every metric helps you understand who is attacking, from where, when, how, and how effectively your defenses respond. This data-driven approach enables you to justify investments, optimize operations, identify defense gaps, and continuously improve your security posture. Vigilant doesn't just protect, it provides the intelligence to make smarter security decisions. Event Logs and Audit Trail. Welcome to the Event Logs and Audit Trail module. This is your comprehensive security forensics and compliance center, where every network event is logged, searchable, and preserved for investigation and regulatory requirements. Let's explore how this module supports both security operations and audit compliance. Event History. The Event History table is the complete chronological record of all network activity processed by Vigilant. Each entry captures critical forensic details, including the event ID for tracking and correlation, the precise timestamp down to the millisecond, the source and destination IP addresses, ports and protocols used, the event type or classification, severity level, and any flags or tags applied by our detection engines. This comprehensive logging serves multiple purposes. For security investigations, you can trace attack sequences by following an attacker's IP address through multiple events, reconstructing their reconnaissance activities, initial access attempts, and lateral movement. For compliance and audit requirements, these logs provide the evidence trail needed for frameworks like SOC 2, ISO 27001, PCI DSS, and HIPAA, demonstrating that security controls are active and effective. The search and filter capabilities are powerful. You can filter by date range to investigate specific time periods, search by source or destination IP to track particular actors or targets, filter by severity to focus on critical events, or search by event type to analyze specific attack categories like port scans or SQL injections. The pagination allows you to navigate through thousands or millions of events efficiently, while export functionality lets you download filtered results for offline analysis or long-term archival. Actions. Each event in the history has associated actions that enable rapid investigation and response. The View Details action opens a comprehensive event record showing the full network packet information, payload data when available, geolocation details of the source IP, threat intelligence enrichment if the IP is known malicious, and correlation with related alerts or events. From any event, you can take immediate protective actions. If you determine an IP address is malicious, you can block it directly from the event log without navigating to a separate page. Similarly, if an IP shows suspicious but not definitively malicious behavior, you can add it to the monitored list for enhanced tracking. For legitimate sources incorrectly flagged, you can whitelist them to prevent future alerts. The audit trail feature logs all analyst actions taken on events, who viewed the event, who made decisions about IPs, and what remediation steps were executed. This creates accountability and supports security operations reviews, showing not just what happened on your network, but how your team responded. Event logs and audit trail provides the foundation for security forensics, incident response, and compliance reporting. Whether you're investigating a breach, responding to an audit, or analyzing attack trends, this comprehensive event repository gives you the visibility and tools to understand exactly what's happening on your network and prove that you're meeting your security obligations. Welcome to the Blocked and Monitored IPs module, your centralized IP reputation and access control center. This is where security policy meets automation, managing which IP addresses are blocked, monitored, or trusted. Blocked IPs. The Blocked IPs table displays all addresses currently denied access to your network. Each entry shows the IP address, blocking reason, automatic SOAR detection, manual analyst decision, or threat intelligence match, timestamp, severity level, attack count, and status. This represents your active threat firewall. Blocks can be temporary with expiration dates for occasional suspicious behavior, or permanent for known threat actors and repeat attackers. This centralized view lets you manage all blocked IPs from a single interface rather than configuring multiple firewall devices. Statistics show auto-blocked versus manually blocked IPs, providing insight into automation effectiveness and analyst workload. Monitored IPs. Monitored IPs are your watch list, addresses showing suspicious activity but not yet warranting automatic blocking. Each entry displays the monitoring reason, date added, activity count, dynamically calculated risk score, and escalation status. Monitoring serves critical purposes, tracking borderline cases where you're uncertain if activity is malicious or legitimate, identifying slow reconnaissance attacks over extended periods, and supporting progressive response where IPs automatically escalate to blocked status if suspicious activity continues. Risk scores update dynamically as new events are logged. When a monitored IP's risk exceeds your threshold, the SOAR engine automatically escalates it to the blocked list. Conversely, if activity normalizes and risk decreases, IPs can be de-escalated or removed. Whitelist IPs. The whitelist contains addresses explicitly trusted and exempt from blocking or alerting. These typically include corporate offices, remote locations, partner organizations, trusted vendors, cloud services, and security scanners. Each entry shows the IP address or CIDR range, description of what it represents, who added it, when it was whitelisted, and any expiration date. Proper whitelisting reduces false positives and ensures business continuity. However, it requires discipline and regular review since compromised trusted systems can be exploited by attackers. Best practices include whitelisting specific IPs rather than large ranges, adding clear descriptions for future reference, and setting expiration dates for temporary access. Actions. Each IP list provides powerful management actions. For blocked IPs, view detailed information showing all associated alerts and events, AI explanations, geographic and threat intelligence data, and attack timeline. Unblock with a single click and optionally add to whitelist to prevent reblocking. For monitored IPs, escalate to blocked status if investigation confirms malicious intent, view full activity history, adjust risk scores or monitoring parameters, or remove from monitoring if activity is benign. For whitelist IPs, edit descriptions and expiration dates, temporarily disable entries without deletion for testing, or remove entries no longer needed. Bulk operations enable efficient scale management. Select multiple IPs and apply actions simultaneously like bulk unblock after incident resolution, bulk export for integration with other security tools, or bulk update expiration dates. The Blocked and Monitored IPs module bridges automated AI detection with human judgment. It allows the system to protect automatically while giving you flexibility to refine, override, and customize decisions based on your unique business context. Whether managing a few suspicious IPs or thousands from coordinated attacks, this centralized interface makes IP reputation management efficient, transparent, and auditable. Alert Review, Active Learning. Welcome to the Alert Review and Active Learning module, where human expertise meets artificial intelligence to create a continuously improving detection system. Vigilant learns from your feedback, becoming smarter and more accurate with every decision. Let me show you how this human-AI collaboration works. Key Metrics section. For critical metrics, track the active learning process. Pending review shows alerts awaiting analyst feedback, typically moderate confidence alerts needing human validation. Total review displays cumulative assessments, demonstrating the growing knowledge base improving the model. The accuracy rate shows how often AI classifications match analyst feedback. As you provide more training data, this percentage increases, indicating the system is learning your environment. Total feedback counts all true positive and false positive inputs that directly contribute to model retraining and refinement. Filter controls. The confidence threshold slider lets you focus on alerts within specific confidence ranges. For example, alerts between 60 to 80% confidence represent cases where the AI is uncertain and your expertise provides the most training value. High confidence alerts above 90% are likely genuine threats needing little review, while low confidence alerts below 50% are often false positives. Severity filtering prioritizes high impact alerts. Focusing on high and critical severity ensures you're reviewing the most consequential decisions where misclassification could have serious security implications. The limit control manages alerts per page for efficient review sessions. Requiring review table. This table lists all alerts awaiting feedback. Each row shows the alert ID, timestamp, source IP, AI classified attack type, severity level, and the confidence score indicating how certain the AI is about its classification. Confidence scores guide your review priority. A 95% confidence SQL injection alert needs little review, but a 65% confidence port scan might be legitimate network monitoring. And your feedback teaches the system to distinguish between malicious scans and authorized activity in your environment. Review Alert button. When you click Review Alert, you see detailed information including network event data, payload information, source IP reputation, related events, and the AI's explanation of why it classified this as malicious. You then make a simple but powerful decision. True positive confirms the AI correctly identified a real threat, reinforcing the patterns and features used. False positive indicates a mistake, perhaps legitimate traffic or an authorized tool, helping the model learn to avoid this misclassification. As you review hundreds of alerts, the system builds detailed understanding of your network's normal behavior and specific threat landscape. Details button. The Details button provides comprehensive forensic information without requiring immediate feedback. View the complete event timeline, network packet information, geographic and threat intelligence enrichment, related alerts, and full AI explanation with feature importance rankings. This deep analysis helps you make informed review decisions based on complete evidence rather than surface-level information. Review history table. Review history creates an audit trail showing which alert was reviewed, who reviewed it, when, what decision was made, and analyst notes explaining their reasoning. This history supports quality assurance by allowing managers to audit analyst decisions and ensure consistency. It provides training material for new team members through real-world classification examples. And it enables trend analysis. If certain alert types are consistently marked false positive, you should adjust detection rules rather than repeatedly reviewing the same pattern. The review history supports model retraining. When the AI periodically retrains, it uses this labeled dataset as ground truth to improve accuracy and reduce future misclassifications. Alert review and active learning transforms Vigilant from a static detection tool into an adaptive, continuously improving security partner. Every few minutes, reviewing alerts doesn't just resolve individual cases, it teaches the system, reducing future alert volume, improving accuracy, and tailoring the AI to your specific environment. The increasing accuracy rate isn't just a metric, it's proof this collaboration is working, and your network is becoming more intelligently protected. Detection Rules Management. Welcome to the Detection Rules Management module, your control center for all threat detection mechanisms in Vigilant. This is where you configure, tune, and manage the 4 distinct detection engines that work together to identify security threats. Let's explore each detection method and how you can customize them for your environment. Action buttons. At the top of the page, you'll find key management buttons. Create New Rule allows you to add custom detection signatures or conditions specific to your environment. Import Rules lets you load rule sets from external sources like community repositories or security vendors. Export Rules allows you to share your configurations with other Vigilant installations or back up your current rule set. And Bulk Actions enable efficient management when you need to enable, disable, or modify multiple rules simultaneously. Signature Rules Card. Signature rules represent pattern-based detection, similar to traditional intrusion detection systems. These rules look for specific, known attack patterns in network traffic. Each signature defines what to look for in packet payloads, headers, or protocol behaviors that indicate malicious activity. The card displays how many signature rules are currently active, how many are disabled, and recent detection statistics showing how many alerts these rules have generated. Common signature rules include patterns for SQL injection attempts, cross-site scripting attacks, command injection, known exploit payloads, and malware communication signatures. The advantage of signature rules is their speed and precision. They catch known attacks with very high accuracy and minimal false positives. The limitation is they only detect what they're programmed to find, missing novel attacks or variations of known techniques. This is why Vigilant combines signatures with machine learning and anomaly detection. You can create custom signatures for threats specific to your applications, enable or disable individual rules to reduce false positives, adjust severity levels based on your risk assessment, and set different actions: alert only, alert and block, or silent logging. ML Model Rules Card. ML Model Rules govern how the supervised machine learning classifier operates. Unlike static signatures, the ML model learns to recognize attack patterns from training data and can identify threats it hasn't explicitly been programmed to detect. This card shows the current model version, last training date, detection accuracy on validation data, and the number of attack types the model can classify. Vigilant's XGBoost model currently identifies categories like DOS attacks, port scanning, brute force attempts, SQL injection, cross-site scripting, and malware communications. Configuration options include the confidence threshold, the minimum confidence score required to generate an alert, with lower thresholds catching more threats but generating more false positives. Feature importance settings let you view which network features the model considers most important for classification, helping you understand its decision-making process. Model retraining frequency determines how often the system incorporates new feedback from the active learning module. More frequent retraining keeps the model current with evolving threats and your feedback, while less frequent retraining provides stability. You can also upload custom training data to specialize the model for your specific environment. Anomaly detection card. Anomaly detection identifies threats by recognizing behavior that deviates from normal network patterns. This engine uses unsupervised learning. It doesn't need to know what attacks look like, only what normal looks like. When activity falls outside established baselines, it generates an alert. The card displays the baseline status showing whether the system is still learning normal behavior or actively detecting anomalies, sensitivity level determining how far from normal activity must be to trigger an alert, and detection statistics for recent anomalies identified. Anomaly detection excels at finding zero-day attacks, insider threats, and sophisticated attacks that don't match known signatures. However, it can generate false positives during legitimate changes like infrastructure upgrades, new applications, or traffic pattern shifts. Configuration options include baseline training period, how long the system observes traffic before beginning active detection, sensitivity adjustment balancing between catching subtle attacks and reducing false positives, and exclusion rules to prevent alerts for known legitimate anomalies like scheduled backups or batch processes. Threat Intel card. Threat intelligence integration enriches detection by comparing observed IPs, domains, and indicators against known malicious entities from external threat feeds. This provides immediate blocking of known bad actors before they can even probe your defenses. The card shows active threat feed sources including abuse.ch, commercial feeds, and threat-sharing platforms, the total number of malicious indicators currently tracked, last update time for each feed, and recent threat intel matches. Threat intelligence configuration includes feed management to enable or disable specific sources based on reliability and relevance, update frequency determining how often feeds are refreshed, balancing timeliness with performance, auto-block settings to automatically block IPs matching threat intelligence without requiring ML confirmation, and false positive reporting to flag and exclude incorrectly categorized indicators. The power of threat intelligence is preventive protection, blocking known threats immediately. The challenge is feed quality and relevance. Not all threat indicators apply to every organization, and some feeds may include legitimate IPs incorrectly categorized as malicious. Detection rules management puts you in complete control of how Vigilant identifies threats. The 4 detection engines, signatures for known attacks, machine learning for pattern recognition, anomaly detection for unusual behavior, and threat intelligence for known bad actors, work together to provide comprehensive, layered security. By tuning each engine for your specific environment, you create a detection capability that's both highly accurate and adaptive to your unique security needs. The department management feature provides enterprise-grade multi-tenancy and organizational structure to your security operations. With departments, you can segment your security data across different business units, teams, or organizational divisions. Each department operates as an isolated security domain, ensuring that sensitive threat intelligence and alerts remain visible only to authorized personnel. Security analysts see only the events and alerts relevant to their department, while administrators maintain full visibility across the entire organization. This role-based, department-level access control is essential for large enterprises managing distributed security operations. Creating departments is simple. Just provide a name and description. Once created, you can assign users to departments, and all security events and alerts are automatically filtered based on department membership. This ensures data isolation, improves analyst focus, and maintains compliance with organizational security policies. Whether you're managing IT security, network operations, cloud infrastructure, or multiple regional teams, the department feature scales your intrusion detection capabilities while maintaining strict access controls and data segregation. Department management enables multi-tenancy for your security operations. Segment alerts and events across business units, ensuring analysts only see data relevant to their department. Administrators maintain full visibility while regular users operate within their assigned domain. Simple to configure, powerful for enterprise-scale deployments, department-based access control keeps your security operations organized, compliant, and efficient. User management. Welcome to user management, where you control access to Vigilant. Proper user management is critical for maintaining security operations integrity. Let's explore how to manage users, roles, and permissions. User overview. The user interface displays all accounts with access to Vigilant. Each entry shows username, full name, email, assigned role, account status, active or disabled, last login time, and creation date. This centralized view allows you to audit who has access to sensitive security data, identify inactive accounts for disabling, track user access patterns for compliance reporting, and manage role assignments following principle of least privilege. User roles. Vigilant implements role-based access control with predefined roles for different security functions. The administrator role has full system access, including user management, detection configuration, SOAR controls, and system settings. This role should be limited to senior security leadership. Security analyst can view alerts and events, review and provide feedback for active learning, manage blocked and monitored IPs, and view analytics. However, analysts cannot modify detection rules, change source settings, or manage users. This suits day-to-day security operations staff. Viewer provides read-only access to dashboards, analytics, and reports without action permissions. This supports compliance officers, executives, and stakeholders who need visibility without operational control. Custom roles can combine specific permissions to match your organizational structure. For example, a threat hunter role with investigation permissions, but no blocking authority, or an audit reviewer with access to logs and history, but not live operations. User actions. Add new user creates accounts by specifying username, email, role, and initial password. The system enforces strong password requirements and can integrate with single sign-on for enterprise authentication. Edit user modifies details, changes role assignments as responsibilities evolve, updates contact information, and resets passwords. Disable user temporarily revokes access without deleting the account, useful for employees on leave or accounts under investigation. Disabled accounts retain history and can be re-enabled instantly. Delete user permanently removes accounts. Best practice is disabling rather than deleting to preserve audit trails showing historical user actions. Multi-factor authentication can be enforced per user or organization-wide, requiring additional authentication beyond passwords to significantly reduce credential compromise risk. Audit logging. Every user action is logged for security and compliance. The audit log records logins, alert reviews and feedback provided, IP blocking decisions, configuration changes, and report access. This comprehensive trail supports compliance frameworks requiring proof of data access, enables investigation of suspicious administrative actions, and provides accountability, ensuring all security team actions can be reviewed and verified. Audit logs are immutable and retained according to compliance requirements, typically 1 to 7 years depending on regulations. Session management. Administrators can view active user sessions showing who is currently logged in, from what IP address, and session start time. Suspicious sessions can be forcibly terminated to immediately revoke access. Session timeout settings balance security with usability. Shorter timeouts reduce exposure from unattended workstations, while longer timeouts reduce re-authentication frustration during extended investigations. User management ensures access to Vigilant's security capabilities is properly controlled and audited. Through role-based access, strong authentication, comprehensive audit logs, and active user lifecycle management, You protect both your network and the security system itself. Proper user management is the foundation of trustworthy security operations.